Hello everyone. My name Mutiara Ananda Tallo Ullu with NPM 234111030. Welcome to this video on sample in research methodology. In this session, we will explore what a sample is, how it differs from a population, various sampling techniques, how to determine the appropriate sample size, and common mistakes to avoid. Sampling is a crucial aspect of research that significantly affects the validity of the results. This topic is especially important for students conducting academic research, such as theses or dissertations. Let's dive in and understand how to properly work with samples in research. What is a sample? A sample is a subset of individuals, objects, or elements taken from a larger population to represent the characteristics of that population. In research, it is often impractical or impossible to study an entire population due to limitations in time, cost, or accessibility. Therefore, researchers use samples as a manageable and representative segment. If the sampling process is done correctly, the results from the sample can be generalized to the entire population with a certain level of confidence. That's why understanding what a sample is and how to use it properly is so important. Population versus sample. A population refers to the complete group of individuals or items that share a common characteristic and are the focus of a research study. A sample, on the other hand, is a smaller portion of that population selected for analysis. For example, if your research population is all university students, your sample might consist of 200 students from different faculties. To ensure valid results, the sample must be chosen carefully to represent the diversity within the population. Failing to define your population or select a representative sample can lead to biased or invalid research outcomes. Why is a sample? Sampling is used in research not just to save time and resources, but also to improve the manageability and precision of data analysis. Studying an entire population, a census, can be costly, time-consuming, and sometimes impossible. A well-chosen sample allows researchers to draw conclusions that are valid and generalizable without needing to survey everyone. Moreover, with a properly sized and selected sample, researchers can apply statistical methods more easily, interpret results more clearly, and minimize data overload. Types of sampling techniques. Sampling techniques are broadly divided into two categories: probability sampling and non-probability sampling. Probability sampling ensures that every member of the population has an equal chance of being selected, which makes it more reliable for statistical inference. Techniques in this category include simple random sampling, stratified sampling, cluster sampling, and systematic sampling. Non-probability sampling, used when equal chances can't be guaranteed, includes methods such as convenience sampling, purposive sampling, snowball sampling, and quota sampling. Each method has specific advantages depending on the research context. Explanation of sampling techniques. Simple random sampling involves randomly selecting participants so that each member of the population has an equal chance of being chosen. Stratified sampling involves dividing the population into strata or subgroups and then sampling from each subgroup to ensure representation. Cluster sampling is useful when dealing with geographically spread populations. Clusters, not individuals, are randomly selected. In contrast, purposive sampling, often used in qualitative research, involves selecting participants based on specific characteristics or expertise that align with the study's objectives. Determining sample size. The ideal sample size depends on factors such as the total population, the desired confidence level, commonly 95%, and the acceptable margin of error. A larger population and smaller error margin typically require a larger sample size. One simple and widely used formula is Sloven's formula, where n is the sample size, n is the population size, and e is the margin of error. Additionally, researchers can use statistical software like SPSS, G*Power, or online sample size calculators to determine the most appropriate number of respondents for their study. Conclusion. Sampling is a foundational element in research methodology, acting as a bridge between data collection and generalization. A well-designed sampling process ensures that the findings are both valid and applicable to the broader population. Understanding the different sampling methods, how to calculate the right sample size, and being aware of common pitfalls are essential skills for every researcher. With the right approach, sampling helps to simplify complex studies without compromising on quality or accuracy.